Hello everyone, this is Nilesh. Welcomes you to the class of design pattern. In earlier classes, we discussed about object-oriented analysis and design and solid principles. In the class of solid principle, we implemented one entire case study on food delivery system, and through that case study, step by step, we seen how the solid principles can be implemented while object-oriented software development. We also seen what exactly is a requirement of those concepts. If those concepts break, then how it will impact the development process, and then what is the correct way of achieving it practically. Now, I want to continue exactly same journey further and want to discuss about the design pattern. The question is, what exactly the design pattern is? The design patterns are proven reusable solutions to solve the common well-known problems in software design. These are typically problems you will see while writing object-oriented software, and the basic inspiration is still the same solid principles. It is not talking about what classes or method or interfaces to be written, but it is basic idea like if you are facing this kind of problem, the structure that usually works well with it is something like this. And why you need these design patterns? Because we have the most common problems like complex object creation, or in your code you have plenty of if else's, or you have multiple code which are tightly connected to each other, and there are certain systems which are very hard to change or evolve. And that is the reason we should be able to follow these solid principles and design pattern in order to make the flexible and extensible code. These all design patterns are primarily divided into three categories. One is creational, structural, and behavioral design pattern. I will come to more conceptual stuff bit later. But in this particular class, I'm planning to talk about some most common, some most popularly used design patterns, not theoretically, but in a practical aspect. Again, I'm going to use the C# as a programming language for solving them. However, you can implement them in any other object-oriented language that you want. It could be C++, Java, or Python. While implementing them, if you are facing any problems, feel free to put it in a comment and I'll try to reply that. Now, let us get started with our first design pattern. But before that, whatever code we had already written earlier, let me copy paste that code. So let me go back to my Visual Studio. And you recall, we already had written a code for the solid principle. And in this block code, we had implemented our all food order system. And this is my entire code I'm copying. And let me paste that code into a new project. This is entirely blank file. Let me paste it over here and build and run my application. You will see exactly same output as of the previous class. If you have not really seen this particular code and this particular understanding, I strongly recommend that you should first watch that video on solid principles, or you should refer the tutorial, walk through that particular code, and only then get started with the design pattern video hereafter. Now, in this particular implementation, do you recall that we implemented OCP, that is open close principle, where the different payment processes are followed. The payment processes including the card payment processing or UPI payment processing or cash payment processing. And all of them, they were inherited from the interface that is iPayment processor, which was the basic requirement of our DIP, dependency inversion principle, as well as OCP, open close principle. And then we created the object of the payment processor method in a separate class called as a payment processor provider, where we have written a static create method, and depending on the given mode, we are actually creating the processor and returning it. Here, have you noticed that this provider is a dedicated class, and the purpose of the class is to actually create the object of the appropriate implementation class and return as its abstraction, that is interface iPayment processor. Now, such class which is dedicated to create the object of the appropriate implementation, that itself was our first design pattern. We formally didn't introduce in the previous class, but here let me tell you that this itself is factory design pattern. The factory design pattern concept goes like this, where the purpose is to encapsulate the object creation logic. Here you see that payment processor provider has got the create method, and depending on the given mode, it is able to create the object of given payment processor implementation. It will return the object via common interface, that is iPayment processor. And this will really help me adding the new implementation classes in future without modifying my client code. The client code in our case was food order service. So you can go back to the food order service and you will realize that inside this food order service, we are only dependent on the interface. We are not dependent on a particular implementation. So any new payment processing method can be added without doing any changes into my food order service. And then you see the basic implementation idea over here was to decouple the payment creation from the order processing. The key points for the factory design pattern: the client depends on the abstraction, and factory decides which concrete class to be instantiated. This follows your open close principle along with dependency inversion principle. When exactly the factory design pattern is used? When object creation depends on the input or configuration. In our case, the payment mode, we can take it from the user. Right now, though we have hard coded into main, but definitely we can take it as an input from the user, or we can put it into the configuration. This design pattern is also useful when many related class share the common interface like payment process. After talking about the factory design pattern, it is good idea to get started with our next design pattern. And let me focus onto something called as a discount logic. You have noticed that we had written one discount logic class. And in this discount logic class, we are putting hard-coded 10% discount for the total more than 1000 rupees. But don't you think that in real world, the discount logic is not fixed? You need to keep changing discount logic. Sometimes there may not be any discount at all, or sometimes there might be the flat discount like 10%, or if you are into the festive season, you might want to attract more customers with some additional 15-20% discount. So you want the different discount logic implementation, and you want to plug in any particular discount logic at runtime depending on the choice, depending on the decision of the restaurant owner. How exactly it can be implemented? You might consider getting started with the logic, let's say flat discount logic, and you can use this flat discount logic directly inside the food order service. But if you do so, then your food order service is directly dependent on the concrete implementation, which is again violating dependency inversion principle. That suggests me that it would be a good idea that I will prefer to have a separate interface. So let me write an interface called as I discount strategy. And in this I discount strategy, I will have a method called as a apply discount. Now we can have this flat discount logic inherited from this I discount strategy. And on the similar line, we can now write some additional classes. We can have another class talking about no discount logic at all, where we are returning the discount to be 0.0. Or you can also have the unconditional festival discount. Let's say I'm writing festival discount logic class and there is no condition, but I want to give a kind of a 15% discount to all my customers. That is good enough. Now, how exactly I connect this discount strategy into my food order service class? Let us go to the food order service, and inside this, instead of using the concrete class, let us use the interface like I discount strategy. Initially, you can keep it null, and like payment processor, we can also initialize it via constructor, where we can pass this I discount strategy. This discount strategy, we can store it into our data member. Let me put it like discount logic is equal to discount strategy. Now, whenever we want to apply that discount, we will go to our bill calculation and we will simply make a call to the apply discount. Let us check how we can call it from the main. Over here, let us also create the object of discount strategy. Let's say we are using festival discount logic, and let me pass this discount strategy over here. Let me run this full application and check if this is working. Do you see that on 600 rupees, I'm getting a discount of 90 rupees because it is a flat 15% discount without any threshold or without any condition. That is wonderful. So this particular strategy is working well. If you want it, you can remove that discount, let's say no discount logic, and then you will find that no discount is given and then the actual bill is 600 rupees itself. So this strategy is working really well. Do you know what exactly we had implemented over here? Yes, we have implemented something called as a strategy design pattern. The strategy design pattern help you to define the family of algorithms and make them interchangeable. Why we have used it over here? To apply different discount rules without changing the order logic. And then discount behavior can be switched at runtime depending on the owner's decision. In this particular case, our I discount strategy is the base contract. And then each discount logic was a separate class. Here, the client depends on the abstraction. The client food order service depends on the interface, not on an actual implementation. Yes, you get it correctly. It is dependency inversion principle followed well over here. So this particular design pattern is typically used when the multiple variants of the same algorithm exist, like discount over here, and you need not to have multiple if-else kind of condition. You can take the advantage of the runtime polymorphism and the appropriate discount can get applied over here. That is really a fantastic way of implementing it. Let me tell you, whatever method that I shown you about this strategy design pattern, it was applicable and implementable in all OOP language. But in this particular class, we are specifically talking about the C#, and I told you the .NET has got something special called as delegates. The delegates is another way of implementing the same strategy design pattern. Well, how this strategy design pattern can be implemented using delegates? If you want that, let me go and modify the existing implementation. Before that, I would like to create a copy of this. And then I can implement exactly same story once again, but now using delegate. Now, instead of our interface, let's say I discount strategy, having a single method, let us go for a delegate. How delegate can be implemented over here? We can put it like a delegate keyword, and method return type is double, and it is going to take the argument the double total. You need not to pass anything else over there. This is my delegate declaration. And now I want to implement this discount logic. This discount logic can be written into the separate classes, or you might have a single class implementing all these different strategies. It is absolutely your choice. For sake of simplicity, I will go for writing a single class, and inside that class, I will write all these actual implementations. Let's say this was my implementation of apply flat discount. Let me make this method as static. You can also have non-static method to be used with the delegates. Then let me go with a no discount logic. Again, I have apply no discount and another static method. And let me also add the festival discount method. Let's say apply festival discount. And this is also my static method. How exactly we are going to use it? Let me try to use it into my client class, which is nothing but food order service. And inside this, instead of using the interface, let me use the delegate. Let me also pass the delegate as an argument to the constructor, and I'm storing it over here. Now, when it is a time to apply the discount, at that time, I will have a check whether the discount logic exists. And if discount logic exists, I will call that particular discount logic. So how I can do this? I can check it like this. If the discount logic is not equal to null, then I will call this discount logic. This discount logic itself is a delegate, object-oriented function pointer. So I can directly call it, and then I will get the discount from there. Now let us go to the main and let us pass this particular implementation to the constructor of the food order service. So instead of creating an object over here, let me directly pass my discount logic. For example, I'm applying discount logic applied flat discount. You notice that when the amount is more than 1000, then this flat discount is working. You can check whether it is working right now. No, because the amount is only 600. Let me just do one thing. Let me change the item selection. Instead of having 2 pizza and 2 burger, let me increase to kind of, let's say, 4 pizza and 4 burger. Now you will see that the total amount will exceed 1000, and you should be able to see that the actual discount is calculated. If you want, maybe you can go for unconditional festival discount. So here I'm passing the festival discount. And when I run this, you'll find that the flat 15% discount, 180 rupees, is applied. So what exactly we did it over here? Inside the food order service, we have kept our delegate, object-oriented function pointer. And that object-oriented function pointer is now keeping the address of this apply festival discount function. So whenever while calculating the bill, you come across the discount application, this discount logic is pointing to apply festival discount, and from here the call directly jumps to that festival discount. And that is the reason we are getting the 15% discount over here. You can debug this application and you can check the actual flow of execution. If you want to understand more about the delegates, you should refer our delegates class. Now that you have understood the strategy design pattern, it's time to go for the next design pattern. Do you recall in the last solid principle application, when we stopped, we connected our SMS notification service to food order service. We implemented interface segregation principle, and then we had separate interfaces for SMS, email, and the push notification. Now, I want to take this to the next level. In this particular application, you find that though we had separate interfaces, still my food order service is directly connected to SMS notification service. What if in future I want to go for the email notification service, or think of something entirely different possibility, like once the order is placed, what if I want to update my dashboard, or I want to update my inventory? Can I write the system in that flexible manner? To be frank, with the existing system, answer is no. Every time I want to add something new, like updating dashboard or updating the inventory, I need to modify this food order service. So they are still kind of tightly coupled with each other. This is where the new system or the new design pattern can help me. And that is nothing but observer design pattern, which allows me to take multiple actions on a particular event. So when something is happening, like over here, the order is placed, and I want to take multiple possible actions on that, the observer design pattern is most suitable. The question is how to implement it. To implement it, you need to get started with the interface. Let's say that we have an interface called as a order listener interface. And for that, I will write the method, let's say on order placed. You might be interested in having the information like cart item, and you can also pass the total amount. Now, for this listener, we can have different action implementation. One of the action implementation could be SMS notifier. And this SMS notifier is inherited from I order listener, where I want to use my SMS notification service, and using that notification service, I want to send the message. How I can do that? Let's say, let me write the method public void on order placed, and let me use notification service dot send method. Great. This should not be limited to the SMS notification. As I was talking about, I might be interested in updating the dashboard. If I'm interested in updating the dashboard, I can have, let's say, dashboard updater. That is again inherited from I order listener. And inside this, I want to update the dashboard. Let's say I want to put a simple console.writeLine message where I'm saying that the new order is placed with total amount so and so, and the number of items is equal to items.length. That is great. You can also add the method for inventory updater into a new class. Now that you have multiple different listener implementation, you need to ensure that these implementations are invoked when actual order is placed. And very importantly, we are talking about the multiple implementations might be called. In that case, you need to link it with your that class in which something is happening, in which the event is occurring. Let me put it over here as a list of order listener. And in this list of order listener, now we can have certain method like add listener. Let me add the method, something called as add listener. Good. And apart from that, you can also have the method which will call all the actions in that particular list. How you can do that? Let's say we can have the method, let's say notify listeners. And in that, I will use a simple for each loop. And with that for each loop, for each listener, I will call the method on orders placed. That's it. Nothing else to be done over here. Now, how do I use it? Now you'll find that whenever the order is placed successfully, instead of directly sending notification service, what I'll do is I will call that method notify listeners. And this notify listeners method is internally dealing with the list of listeners, and whatever listeners are registered, we are actually calling the method on order placed. I guess that is great. Let us try to call it from the main. At this moment, you do not find any listener right now registered. So if I run this full application, you should be able to see a very basic stuff. No SMS is even sent. Now, let me add the listener into this. Let's say service dot add listener, and I have added my first listener like SMS notifier. Let me run this. And do you see that it is sending the SMS? Not only that, again, if I want to update the dashboard, let me again go for adding another listener, that is nothing but dashboard updater. And let me run it once again, where you see that even my dashboard is also updated. Here you can see that I have totally decoupled my action on that particular event from the actual client class, actual class in which the event occurred. Isn't it great? Do you recall that exactly same sort of implementation we had done earlier in C# using something called as events? In C#, we have event keyword, and in the event class, I explained the low balance event in the account, so that whenever there is a low balance, then bank can decide whether to send SMS or whether to do phone call based on the bank strategy. This is exactly the implemented over here with the help of interfaces. If you want to learn how to do it using C# events, please go back and refer that video of events. You can find the link in the description below. So what exactly we have implemented in this design pattern? Let me show you over here. In the observer design pattern, we had used this I order listener, and inside that it is order placed method was given. We had implemented this into the SMS notifier and dashboard updater. You can also add the additional method like email notifier, or for that sake, you can also go for the inventory updater. And then this listener was then connected with food order service, and we maintained the whole list. Now, whenever the order is placed successfully, the moment order is placed successfully, we are notifying all registered listener over here. So the observer design pattern is used to notify multiple objects automatically when the state change or when certain thing happened. In this particular case, this food order service is called as a subject in which the event is occurring. And then I order listener is the observer contract. The observers can be added or removed dynamically. And as I said, this can be done, this can be implemented very well in .NET using events. In this particular case, when event triggers, multiple independent actions can be executed, and to maintain low coupling between these subject and actual action components. This explains the observer design pattern. This is one of the very useful design pattern, very commonly seen in typical GUI applications of .NET. Now it's time we can go ahead to our next design pattern. In our next design pattern, I want to talk about the order processing in the different pattern. Like this particular application is only related to the food order delivery. But don't you think that it can be extended to maybe takeaway orders, or it can be further extended to the even dine-in order? So if I want to make my application extendable, what I can do? But before you think of the actual implementation, please note that irrespective of whether this particular order is delivery or takeaway or dine-in, the basic process is still same. We still want to select the items. We still want to calculate the price. We still want to get the discount. We still want to payment the process. And then we want to notify the listeners. Exactly same process to be implemented everywhere. If it is same process to be implemented everywhere, if the same logic is to be written everywhere, then directly writing independent classes may not be a good choice. So what I suggest over here is we can write one base class, and that base class could be kind of order processor class. In this order processor class, at the moment, I'm passing the payment processor as well as discount strategy. Good. And then we have exactly similar logic like placing order and all that kind of stuff. Now we can go ahead and we can implement the delivery order service. Delivery order service will be inherited from our order processor. In this particular case, we want the similar functionality. That's why the class is inherited. But over here, I can have some additional functionality. The additional functionality, like it could be some sort of a delivery address that I'm looking for. And then rest of the functionality will be always same. In fact, I'm thinking of I can also have some method which will display my order detail. I can have such method in the base class and then override it in the derived class. But the base class method will be kind of limited. So instead of writing some damn method over here, let me write one abstract method over there, like display order details. And this particular method, we can override it in the derived class. One more point, if you want to override this particular method in the derived class, then all these data members should be accessible in the derived class. To make it accessible in the derived class, you can quickly make them protected instead of keeping them private. So let me modify them and make it protected. Now, let us try to implement this method. Let's say display details. And in these display details, yes, we are displaying the delivery address. Apart from the delivery address, I want to also display all my item details. How I can display the item details? Let me print it. The item details over here. Item name is so and so. This particular order is typically my delivery order. Now, while writing this particular constructor, we need to take all the arguments of the base class as well as we need to also consider the address over here. So let me write the constructor for this. The constructor which is taking the base class arguments, and then in this constructor, I will also add the address. This address, I will initialize it over here. And the base class constructor will take care of initialization of the processor and discount strategy. That's wonderful. Now, you need to also take a look at one more thing. Since we have mentioned the display details method as abstract, don't you think that I have to also make this particular order processor class as abstract class? And then my implementation of the delivery order service is ready. The way we have implemented delivery order service, we can now also implement the takeaway order. Let me quickly copy paste this. And in this takeaway order, we will have the similar logic. Only thing, I will probably change the address to some pickup time. And this pickup time, again, I will take it as an argument from my constructor. Let me modify this to the takeaway order, and then I will simply display the pickup time is equal to the pickup time. I can implement one more class. Let's say dining order. Let's have a class dining order, which is also inherited from the same order processor. And inside this, I want to write the similar logic. But in that particular case, I want to take the public string, let's say table number. Let me write the constructor, which is taking the payment processor, discount strategy, as well as the table number. Let me call the base class constructor, and over here, let me initialize the table. Now we can also have that display details method overridden over here, and which is mentioning it is a dining order at so and so table. This is very simple and straightforward implementation. If you also want to make some common logic or probably little more readable logic, you can have some more changes into the base class. Let's say in this particular case, I'm calculating the price as well as I'm then finding out the discount and then getting the total bill. This particular logic can be put in into the separate method altogether. So let me use a method called as calculate bill. And that calculate bill is doing all the calculation and giving me the final amount over here. This is actually making call to the discount logic to calculate the discount as required. We can also check for the null if you want it. Anyway, let me try to run this and cross check if this is working very well. To run this, I need to do a very small change into the main where order processor is equal to, let's say, delivery order service, and let us try to get the delivery at 8 p.m. It's good. Let us try to run this application and you see the output. Do you see that this particular order is then placed? But have we displayed the details? Not yet. Let me do one thing. Let me also display the details. And that I will do it over here. Service dot display details. There you should be able to see the actual details. Like this is a delivery order of 4 pizzas, 4 burger, and then delivery address is at 8 p.m. You can definitely add the additional information like total bill and etc. because we have simply kept all those members as protected. So you will have direct access to all those relevant data members from the base class. That's great. But what if I want to change it to the dining order? To change it to the dining order, all I need to do is order processor service is equal to new dining order service. And over there, I want to mention that table number 5. Let's see if I run the same thing once again, you should be able to see that, yes, this is a dining order to be served at table number 5. So what exactly we implemented over here? In this particular case, we have one base class called as a order processor. And this base class is having all core logic required for the order processing. More than that, it also have one method, let's say place order, which define the exact process how this entire order should be processed. Now we can write the subclass, and subclasses could be the delivery order or a takeaway order or dining order. Don't you think that for all of them, my basic order, place order, logic, algorithm will remain exactly same. If you at all wish that this particular stuff should be modified into the derived class, if it is required, you can try to keep it virtual. And if at all subclass demands it to be modified later, yes, they can override it. If you want, no, this particular logic should be kept fixed for all derived classes. In that particular case, you may not keep it virtual. You may simply keep it a final or sealed method so that the derived class can never modify the basic steps of the placing order. This is kind of a freedom that you are getting over here. This particular stuff is referred as template method design pattern. Let me show you what exactly we implemented over here. The template method design pattern is defining the skeleton of an algorithm like placing order in the base class, and subclass may do the customization of certain steps as per their requirement. Here we have written the order processor as a base class, and then delivery order, takeaway order, and dining order. These are the subclasses implemented. In this particular case, you will find that the place order is a template method, and then subclasses can override certain methods, maybe calculate bill, display details, or if you want, you can even make that place order as the virtual method. Here, we are allowing the code reusability, but the extension is controlled because the basic template of placing order is kind of fixed over there. This particular design pattern is used when algorithm steps are fixed, but details may vary. And this is to avoid the duplication in related workflows. One thing that I want you to notice over here, in this particular case, we have not really used the interfaces. Rather, here we are relying on the abstract classes, because in this particular case, order processor class doesn't contain only the contract. It contains the relevant data members. It contains the initialization logic. It also contains my template method implementations. And one method was abstract. That is the reason the whole class was declared as abstract. It is not compulsory that this kind of base class has to be abstract always. You may also have the display details method as a normal virtual method, which is providing some basic details, and the additional details can be provided by the subclasses. I hope this gives you clarity on the template method design pattern. Now that you have understood the template method design pattern, it's time to go for the next design pattern. The next design pattern where we are trying to refine this billing functionality. Right now, our billing was very simple, very straightforward. All we did in this bill was just to give some price calculation and putting some discount on the top of it. But don't you think in real application, you might need certain add-ons on that particular bill? You might have some sort of a delivery charges. You might have some sort of a packing charges. You might have the taxation in all the countries. And then this bill calculation logic, step by step, will start growing. So how exactly we can do billing more effectively in this particular system? To do the billing more effectively in this particular system, I suggest we will write another interface for billing, and then we will try to implement certain add-ons on the top of it. Let me show you with example. This particular implementation is typically referred as the new design pattern called as Decorator design pattern. Let me first show you the implementation, and then I'll take you to the concepts of it. So let us consider I have one interface called as bill interface. And in this bill interface, we are kind of returning the calculate bill, or maybe I can write it simply get amount. Now, let me first define my basic bill, and on the top of it, we will talk about the add-ons, the additional taxes or additional charges that you want to apply. Let us talk about the basic bill. And this basic billing has to be done. You need something like an item selector, and then you need the price calculation for that. That can be done quickly by using item selectors and price calculator. I'll use a constructor to initialize it. We will have get amount, where we will get the items, and from that items I will use price calculator, which will actually calculate the price. My basic bill is ready over here. Now our base bill is ready. So let us go ahead and try to provide the discount on the top of it. For that, I will write a separate class called as a discount decorator. This is also inherited from the same interface I bill. Now in this particular decorator, we will try to get the original bill, and for discount, we also need the discount strategy logic. Now we will write this particular get amount class, and in this get amount class, we are having the bill old amount. Then we will call the discount strategy that will give me the actual discount, and that discount I will minus it from the amount, and whatever is modified final amount that I will return from here. So discount will change my basic bill amount. On the similar pattern, we can also have some additional decorators. Maybe I want to write additional decorator called as, let's say, packing charges decorator. That is again inherited from the same I bill. Again, I will have the basic bill, and then I will have certain packing charges over there. For time being, I want to make these packing charges kind of hard coded. Let me consider the packing charges to be ₹50. And then we will again get the basic bill amount, and in that bill amount, let me add those packing charges on the top of it. Going ahead, you might also look for the taxation decorator. So let me have the tax decorator over here. Again, we will have the similar pattern. Again, we will have the basic bill, and then we will have some tax. Let me again consider the tax hard coded to, let's say, 15%. So this dot tax is equal to 0.15. And then we will apply that particular tax into the amount, and then the total amount we are returning from here. So have you noticed that we have written first a base bill? On the top of it, we have created like a discount decorator. And then on the top of it, we have used the packing charges decorator. You may also have the delivery charges decorator. We have not written it right now, but we can consider implementing that as well. And then we can also have kind of a tax decorator. Now you need to also understand that for the different type of order, we will need the different add-on. Like if it is a dining order, for the dining order, what we need is a basic bill. We will need the discount, and then we will need the taxation. But if we are going for, let's say, takeaway order, the takeaway order will have basic bill, discount, taxation, plus it will also have the packing charges. But when we go for the delivery order, it will have the basic bill, discount, then packing charges, plus delivery charges, and then taxation. So depending on the different requirement, you might want to add or subtract these decorator add-ons. And that is the beauty of the decorator design pattern. How exactly I will use it? Let me apply the basic decorator concept into the calculate bill function in my food order processor. And inside this, I will use my decorator. For that, let me quickly first create the basic bill. On the top of it, you might want to add the discount. So let me have a discount created over here. So new discount decorator. And this discount decorator will take the bill and it will also take the discount logic. And whatever modifications are done, that is giving me the new bill. Now on the top of it, what I need is the taxation, because that is common for all the methods or all the type of orders. So let me go for new the tax decorator. Again, I will pass the bill and then the modified bill object will be returned back to me. And then finally, I will use that bill dot get amount over here. This is nothing but my basic bill. But as I said, this bill we will need to change into our subclasses. So let us keep this method virtual in the base class, and I can override this method in the derived class. Now consider that I want to go for this, let's say, delivery order service. For the delivery order service, let me apply the same logic. Let's say override calculate bill. And inside this, the same logic that I will use it. But in this particular logic, I want to also add one extra thing, that is nothing but the packing charges. So you find that the packing charges are added after the given discount. As far as delivery is concerned, you may also write another decorator, let's say delivery decorator, and you can add the delivery charges on the top of it. I leave it as a homework for you. Now you will see how exactly my billing is calculated. So let me run this full application and let us check what is the current status. Currently you find that this particular order is a dining order, and on 1200 bill I'm getting 180 rupees discount. However, the actual payment amount differed. It is because of the taxation added. But wait for a minute. What if instead of dining order, if this order is a delivery order, don't you think that 50 rupees of the packing charges will be added to that? And plus the taxation will be on the top of it. So you find that the 50 rupees plus tax is added over here. You find that how changing one place, like changing from dining order to delivery order, automatically my bill calculation is modified. So what exactly we implemented over here? We implemented decorator design pattern, and decorator design pattern will add responsibilities to existing object dynamically without modifying the existing code. Over here, we use that decorator for our billing, where we are combining taxes, discount, packing charges, and so on. If I had not used the decorator design pattern, what would have happened? Then there might be only one billing class, and all that logic I will keep putting it into the same class. And then slowly, my class is growing with the size. It becomes bulky. So the decorators implement the same interface as of the base bill class that you have noted, because these decorators are actually doing the replacement of your basic billing interface. Do you recall the list cost substitution principle? Yes, that principle applies well to decorators. Over here, the behavior is added by wrapping the existing object. So our base bill is wrapped into discount decorator, which is then wrapped into the packing charges and then to the tax decorator. Also, another thing to note is order of decoration might be important, because if I apply tax decorator early, then I will be putting tax only on the basic bill. I may not be putting taxes on the packing charges or delivery charges. That is the reason in which order you want to apply this decorator, that is really important. So the decorator design pattern is used when we need to add the features at runtime. And in that case, inheritance may not be the good choice. It might be a very stubborn choice or very rigid choice. After you understand about the decorator design pattern, now it's time to go one step ahead. Just now, we were talking about this particular billing calculation. And in this particular billing calculation, you have noticed that I'm actually creating a bill, and in that bill, I'm putting the add-ons one by one, which is eventually making this particular bill object creation itself as a complicated process. You can see this kind of complicated process over here, where you are trying to wrap the basic object with first decorator, second decorator, third decorator, and so on and so forth. In this case, there can be another design pattern which will help you to create such complex objects easily. And the next design pattern is basically the builder design pattern. To implement builder design pattern, let us create a new class, and I will create a class called as bill generator. You may also name it as bill builder or any other class as of your choice. And this block class, I will encapsulate my basic iBill interface. Now, while creating a new bill over here, I need at least two things. I guess item selection, and I need the price calculation. Using that, I can create a new bill first, and this particular bill is ready, which can be written using a method called as a get bill, or you may call that method as a build method. So let me write the method get bill. This is actually returning the basic minimal bill object. But what if I want to add these add-ons one by one? Let's say I want to look for the discount. Let me write a method called as a with discount. And this with discount method, I need to pass the discount strategy. In this discount strategy, I want to create the discount decorator, and that will wrap my existing bill. Please note here, I want to return the builder object. And to return the existing builder object, I will simply say return this. Why I'm returning this builder object once again? You will understand it better. Let me just right now tell you that this will provide me something called as a fluent API, which can be cascaded to each other. Just wait for a minute. As we reach to the implementation, things will be clear. Let me apply the next stuff on the top of it, which could be, let's say, with packing charges, where I will create the packing charges decorator, and again, I will return my bill generator. In the similar way, I can have the delivery charges decorator, or we will also have, let's say, tax generator. Let's say bill generator with tax method. Again, inside this, I will use the tax decorator, and I will return the bill generator once again. Now, my packing charges and the taxation is ready. So this create my bill generator class. Wherever I want to create the bill, instead of creating the bill one by one and adding decorator on the top of it, I will prefer now my bill generator. How I can do that? Let me take you to the bill calculation logic. And this particular logic, we will actually replace it with our builder. How we can do that? Let us compare this code right now. Let me first create the bill generator. And in this bill generator, at this moment, I want to add the decorator. So we can add the decorator like this, saying that dot with discount, and you can pass the discount logic. The next thing I will simply say it is a with, let's say, tax. So I will add with tax over here, which will return me the bill generator once again. And from that bill generator, I will actually get the bill. And that get bill will return me the bill interface. This particular bill interface I will use, and then I will return the actual bill amount. Purposefully, I have kept the code in front of you. Whatever we did over here manually, exactly same thing we have now achieved using our builder design pattern. So let me remove this code and let me only keep the code of the builder design pattern. Let us apply exactly same thing for our next class. Let's say delivery order service. In delivery order service, let us repeat the same logic once again. Let me create the bill using builder pattern. So we have something called as a bill generator. Bill generator object, let us first apply the discount. After the discount, I want to put the packing charges. Then I can apply the tax, and then I will get the bill. And whatever is final bill amount, I'm returning from here. And you know that exactly same logic, we will use it for the takeaway service as well. This is nothing but the builder design pattern. Of course, my result output is going to remain exactly same. No change in the output is expected, irrespective of whether it is dining order, whether it is delivery order, or whether it is a takeaway order. So what exactly we implemented over here? We implemented builder design pattern, and it is primarily used when you want to construct the complex objects step by step. In this particular case, we have done bill creation that involves the optional component. You must have noticed that the packing charges or delivery charges, these are kind of optional components that we have. It makes our code more readable, and we not to have that one big constructor with all possible parameters. This is a concept where we have implemented Fluent API. What is exactly the Fluent API over here? The Fluent API over here, in this case, you've seen that each method is returning me the builder object once again. And then that builder object, we are again calling the next method, which is again returning me the builder on which I'm calling the next method. So this will help me to cascade all this logic one after another. And that idea is nothing but called as a Fluent API. If you had came across the string builder class in Java or like .NET, that is also a typical implementation of the builder design pattern. Over here, the same construction process and different objects you are able to create. So in some cases, you may skip the packing charges, or you may skip the delivery charges, and so on and so forth. When builder design pattern is used for the construction of complex objects, and where we have certain optional parts involved. Before I finish my discussion on builder design pattern, let me tell you that in this implementation, I have used the combination decorator plus builder design pattern. However, you can go for the builder design pattern alone without having decorator. What is important is that you want to create the object step by step with the optional parts. Now, after understanding the builder design pattern, it's time to talk about the next design pattern. And this design pattern is very popular, well-known design pattern called as Singleton design pattern. In our application, there are many times requirement to have certain settings, certain object to be accessible throughout the application. And that system can be implemented using Singleton design pattern. We had already implemented singleton design pattern in our static class. But let us implement it once again over here with the current food order system application. In singleton design pattern, it is ensure that the class will have only one instance and it will be accessible throughout the application. And this is commonly used for the configuration or logging or caching. These are certain common system applications available. Now, how we are going to make singleton in this application? Do you recall that in our application, we have made certain things hard-coded, like the discount threshold or tax percentage or the discount rate. These are few things we had hard-coded in our application. So instead of hard-coding it, let us put it as a configuration. Ideally, we can put all that configuration into one file and then we can read it. But there is no point in like reading that configuration again and again in our application every time we need it. It will be really great idea that if we load all that configuration and keep it in some global object, and from there it will be accessible everywhere. And that is the perfect use of the singleton design pattern. So for that, I will prefer to write one class called as a class app config. And in this class, let me provide certain settings. Let us have some setting like payment mode. I do not want all these settings to be done externally. So I can put the setter as private, which will be initialized only from inside this class. We can also have additional settings like festival discount. We can also have the setting, let's say flat discount. We can also have the discount threshold. Apart from this, let us go for billing related stuff like packing charges. We hard coded it to 50, but if we want, we can modify that. We have also given tax percentage. If you want, you can add many more details over here. And I want this detail to be initialized only once. So I can write that code into the constructor where we will read from configuration file and set into our properties. However, for sake of simplicity, let me avoid reading from the file. I will only simulate it and I will prefer to hardcode that data over here. So let me mention, let's say payment mode to be UPI. And then you can give, let's say festival discount to be, let's say 20%. The flat discount to be, let's say 10%. The discount threshold is 1000. The packing charges is 50 rupees. The taxation, let's say I want to put it, let's say 5%. And these are certain details that I want to give. But the question is how I ensure that there is going to be the single object of this class. To ensure that the common method of implementing singleton is first step to make the constructor private, which will give me guarantee that no one can create the object of the class from outside the class. Now, if no one can create the object from outside, you want at least one object to be created from inside. And for that reason, let me also make one data member like private. I can make it static, read only, application configuration instance. And this configuration instance, you can initialize directly into the field initializer, or you may initialize it into the static constructor. If you are working in Java, you may go for the static block if you want to write some additional logic over there. The last point is how I make this particular application configuration accessible outside the class? Well, I can write a simple property for that. And that simple property will simply return that instance. You can write like a get instance method, or you can actually write the property itself, which is returning that instance as per our requirement. That's it. This makes my singleton class. Now, whenever I need this functionality, I will directly use appconfig dot its static property instance, which will give access to the object, and then those object members we will try to access. How? Let me show you over here. Over here, we have hard-coded the mode. Now, instead of hard coding, let me use appconfig dot, let me use that instance, and from that, let me use the payment mode, which is right now initialized to UPI. As I said, you can have the separate properties file, and from that file, you can change, and updated changes will be available in the next run of the application. Not only that, let me also do the changes into other places one by one. Let me find out the another place where we have done hard-coded value. Like, for example, we have done value hard coding of tax over here. Let me change it to application config dot instance dot tax. And then we also have the packing charges over here. Again, I can use application config dot instance dot packing charges. Continuing further, here we have hard coded the cache limit. Let us modify the cache limit over here, like appconfig dot instance dot cache limit. I guess I forgot to add cache limit as a property over there. No worries, I will add it into appconfig class later. Apart from this, there was also requirement of applying the discounts. So let us use the festival discount over here, appconfig.festival discount. And then I also want to change the flat discount. The flat discount is given over here. But there was also one discount threshold. Let me have the discount threshold to be used over here. Whenever total is greater than discount threshold, then and only then I want to apply the flat discount. That's great. Now, I guess only the cache limit is not added into the app config. So let me quickly add the cache limit over there. Let's say public double, and I want to use cache limit. And this cache limit, I want to set it to 500 rupees for now. That's it. Now, nothing is hard coded in my application. Let me run the application, and this should again bring exactly same output for me. Let us check what exactly we did over here. We have done the centralized application configuration, and the consistent configuration is shared across the whole system. While using Singleton, it is usually considered a good idea to use the same object or read-only data accessible throughout the application. Modifying data in the whole application is considered to be the bad choice or considered to be bad design. So we have taken a good example of Singleton over here. And to implement Singleton, as you have noted, we have used the private constructor and one static instance that we have. This is giving me the feel of global, but with the read-only data, we have ensured that we provided the controlled access to the configuration like payment mode, tax, or packing charges, and so on and so forth. I hope you realize the actual use of the Singleton design pattern in the real application. Now we can move to the last design pattern. And this last design pattern is about the adapter design pattern. Let me give you one situation. You recall that we have implemented different payment processing mode, and these payment processing mode are like card payment or cash payment or UPI payment. In future, if we decide that we will upgrade to some payment gateway system, how exactly I can use the payment gateway in my application? Now, let me tell you the real challenges with the payment gateway. First of all, payment gateway is a third-party system. The payment gateway is not really the part of your application. So you cannot really go and modify the code of the payment gateway. Whatever way payment gateway is been provided by the respective company, you have to adapt it into your application. But while adapting to your application, you still want to ensure that your existing client code should not be broken. Your existing the food order processor should not be modified, but you should be using display interface effectively so that you can connect to available third-party service. So how exactly it can be implemented? Let me implement it, but before that, I would like to comment this code, and then we will go for our last implementation of design pattern. In this particular case, what I will have, let us talk about what kind of code is provided by the payment gateway people. So there are quite good chances that payment gateway people must have provided their own contract. Let us consider that that particular contract of that third party payment gateway is, let's say, I payment gateway. And inside this, let's say it is having some method called as a make payment. This particular interface is implemented by this payment gateway. Let's consider the name of the payment gateway as something, let's say, well-known payment gateway. And they have already implemented this make payment method. I just want to make it sure that this particular code is the third party code. And in real world, you do not have access to this code, or you do not have authority to modify this code. So this is third party implementation. The question is, can I use it in my payment processor? If you look at your payment processor, there is method named as process payment. Plus, it is having additional method called as a can pay. But the problem is over here, the name of the method is make payment. So somehow these methods are not directly compatible with each other. How I can then implement it? So let us apply some logic. Instead of using this iPayment processor into these classes, which is not possible, why not to write my own new class called as gateway payment processor, inherited from iPayment processor. And this gateway payment processor will internally connect to the given interfaces. Let's say we will use iPayment gateway inside this, and that is connected to well-known payment gateway. Now, in this particular gateway payment processor, I have to implement the method of iPayment processor, which is process payment. And inside this, I can actually make a call to my gateway. So this gateway dot make payment. That's it. This is how I'm able to do the payment using the gateway processor. Let's see if I can use this payment processor instead of the card or UPI payment processor. For that, what I need to change? Yes, you guessed it correctly. I need to add the additional payment mode into my factory. So let me go back to the factory, and into the payment provider, let me add another option. Let's say mode is equal to gateway. Then I want to return new gateway payment processor. Let's see if this gateway can work well over here. Currently, application configuration is set to UPI. So let me just go back and let me try to modify it. So let me go to the code, and instead of UPI, let me consider the gateway over here. Let me run the application. Wow. In this particular case, the payment is made from the payment gateway. This is wonderful. So what exactly we did over here? In this particular case, you have noticed that we already have the iPayment processor interface in our application. And the third-party systems have given iPayment gateway interface, and they already had implementation of the well-known payment gateway. What exactly I did? We have written one extra class called as a payment gateway adapter. And what this class is doing? This class is simply making call to actual make payment implementation done in well-known payment gateway. This is how we are able to connect our existing application to the third-party system without doing any changes in our food order system. So this adapter system is designed for implementing the client interface, and it delegates the call to the incompatible interface provided by the third party. It promotes reuse of the existing components like iPayment processor and its design. When we should be using this adapter design pattern? The primary use of the adapter design pattern is to integrate the legacy and third-party system. And when our interfaces are not matching as per the requirements given in the legacy application or third-party system, I guess that was our case. And then we have implemented adapter design pattern successfully. So far, I've shown you implementation of the most common or most popular the design patterns. Now it is time to go back to the concepts of design pattern. So as I said, design patterns are proven solutions to the common software design problems. And as per the original book of Gangs of Four book, which is very popular by this name, it is a book titled as Design Patterns, Elements of Reusable Object-Oriented Software. This particular book is mentioning the 23 design patterns, and that is considered to be most authentic source on design pattern. According to that book, all these design patterns are divided into three categories. The first category is a creational design pattern, talks about the object creation mechanism, and it has got around 6 design patterns. Then structural design pattern, which is having composition of classes and objects, so which is having the 7 design patterns. And then we have the behavioral design pattern, which is interaction and responsibility between the objects, which has got remaining 10 design patterns. Out of this, what we have implemented is factory design pattern. We implemented Singleton design pattern. We also implemented builder design pattern. From the structural, we implemented the adapter design pattern, the last one, and we also talked about the decorator design pattern. From behavioral category, we talked about like strategy design pattern. We talked about the observer design pattern, and we also implemented template method design pattern. Purposefully, I selected these design pattern from the different category so that you get the idea about these design pattern classification. Let me quickly talk about these categories in short. So creational design pattern talks about who is creating the objects or how objects are created. When objects are created, they are going to hide the complex logic of the object creation. You can quote it like the creational patterns help you to create objects in a smart way instead of using just a new operator. The typical examples are Singleton design pattern, factory design pattern, and build a design pattern, we implemented all these three. The next category was structural pattern, which talks about how our classes and objects are connected to each other. It tells you about the structure, organization, and relations of the classes. It talks about how the objects talk to each other. And then it also tells you how you can wrap the objects like decorator, or how you can adapt the objects. You can quote it like structural patterns help you to arrange classes so that they work together cleanly. The typical example, as I mentioned, is adaptive design pattern and decorator design pattern. The last category was behavioral pattern, which talks about how these objects communicate and behave. Here we discuss the object responsibilities. We talked about the communication between the objects and the flow of control. The behavioral pattern defined how objects talk to each other and share their work. A standard examples are like strategy design patterns, observer design pattern, and template method. Yes, we have implemented all these three design patterns. Purposefully, I took the example from each category where we talked about the creational, structural, as well as behavioral design pattern. Of course, there are the other design patterns also available. If you are fresher or beginner, these 8 design patterns are most commonly seen and most frequently asked in the interview. I'm sure it will be helpful to you. If you also want to go ahead and dig the further design patterns, this understanding can help you. Or if you want me to talk about some specific design pattern, please post it into the comments. I'll try to make a separate video on this. I hope you will implement this whole implementation step by step to gain confidence on the design pattern and crack your interview. Thank you very much for listening patiently. See you in the next session. Bye bye.